Thanks everyone for joining from a very sunny London. It's actually kind of nice. So as Diego said, this is a webinar called Building Scalable, Repeatable Infrastructure in the Cloud. Basically, I am going to demonstrate using the practices of infrastructure as code how we would deploy a TeamCity instance in the cloud. I am Paul Stack, as was said. You can find me on the internet, Stack72. I have a blog and stuff. You can follow that and find some links around that later. So we're going to quickly talk about the evolution of infrastructure management. Over the decades that systems have been around, there has been a different way of managing infrastructure throughout the ways. And some of the older methods are still used even today because that fits the way that suits the business. But as we go through and we see that the cloud has changed things had to change. So Snowflake Servers. Snowflake Servers was a term coined in 2012, and it's the idea that a server is manually configured and it's long running. Okay, it usually relates to physical infrastructure. So in a colo data center, or if you have your own server room in your office, something like that. Basically, if you have a cluster of servers, you cannot guarantee that every single server in the cluster is the same, because many people will have made changes to them over a long period of time. And there will be a way of doing it, but not everyone is very good at following a specific procedure. They're known as snowflakes. Everything is slightly unique to each other. And what usually happens is we usually have a runbook. And runbooks are usually created in Word documents. They're maybe updated a couple of times. You've probably got some screenshots in there from previous versions of software. Those screenshots have never been updated, so it's very difficult to try and follow all the different pieces of the infrastructure that you actually need to change, because your runbook doesn't really relate to what's the state of your infrastructure right now. So what we actually get at that point is we have our servers as like pets. Okay, they have names, they're cared for. If anything were to happen to it, we would be very upset. It's our pride and joy. So we treat it like so, and we nurture it in that way. Building for the cloud is a different paradigm. You cannot guarantee that a server that you create today is actually available tomorrow. So we needed to change how we managed infrastructure when we moved to the cloud. Configuration management tools were introduced. Not for the advent of the cloud, but they have been very popular for the advent of the cloud. We could specify the state of our infrastructure, and we would be confident that a configuration management tool would actually bring that infrastructure to the state that we required it to be. So it's a very declarative way of building your systems. This is actually classed as Phoenix servers. Phoenix servers is another word that was another term that was coined in 2012, and it was basically the thought process that a server could be killed off at any point, and we would be confident that we could bring up a replacement server in its place because it was configured and actually specified as configuration and how we determined the server will be brought up. But with great power comes a great responsibility. There was a recent server fault hoax question where someone actually suggested that because of a configuration management tool, they made the mistake of deleting everything within their server infrastructure. So this shows the dangers. You can actually cause real problems when you have the power of a configuration management tool, and you have to be very wise in how you use it. But without these tools, you can't really guarantee that your infrastructure is in the state that it should be. We can manually created tooling or manually created servers can't guarantee that the level of patches on the server are the same as the level of patches on the QA server, or that the developers are creating software against a specific version of an operating system and we've actually got a different version of packages in the operating system in production. And we do get into fire state. We do cause real problems, and we can actually find that that's not really the best way either. Configuration management may not be the silver bullet in systems management. So in 2013, Chad Fowler actually wrote a blog post about immutable infrastructure. And what he basically says in the article is, you build once, if changes are needed, then we rebuild it. This is really good because we can test the creation of our infrastructure. We can include tests as our infrastructure is being created that we run again and again, and before we deploy that actual infrastructure to production or whatever environment we choose, we can be confident that it's fit for purpose. If from the engineering software background, it's exactly the same process as unit testing and acceptance testing. We want to bake that as part of our process. Now, it's not truly immutable, as what has been talked about in the past few years, because things on servers do change. So logs, users, people SSH into servers and so on, and RDP into servers. So maybe immutable is not the correct terminology for it. And last year in 2015, Mark Burgess actually suggested that maybe disposable infrastructure is a better way of thinking about it. So servers are actually made in order to be disposed, or in order to be happy that they can be disposed of, and we can continue our applications and our systems without that specific server. We think of this as cattle. Okay, servers are much more like cattle now because they're bred for a purpose. They don't really have unique names, and unfortunately, when they die, you're happy to get another one in its place. So that's my slides finished. I'm going to go straight in and start showing some demo code for this. Okay, I'm going to use Terraform and Packer, which are two tools by HashiCorp. Full disclosure here, I actually work on Terraform. I recently joined the HashiCorp organization. This webinar and the code written for this was actually written pre me joining the company. So this is not a sales technique. This is just a tool I actually used before I joined the company. All the code is available on my GitHub. It's the github.com/stack72-webinar. So you can go and find all the code that's there. In a nutshell, Terraform is an infrastructure management tool, and it's based on the utilization of graph theory. So I'm not going to go into graph theory by any means. It's a topic that's way above my head. But to sum up what Terraform does, Terraform creates the relationships between nodes. And a node in this instance is something like an infrastructure, an instance, or a security group, or a database, or a DNS server, or a domain record and something. And it actually understands the relationship and how to build A before B, B before C. C can happen at the same time as D, etc. And we can actually have a look at what that does, because Terraform has the idea of a graph built in. And I have a tiny package on Mac called Dot, so I can pipe the Terraform graph through it and actually draw what the graph of infrastructure looks like. So if I open my graph, I can actually see that the bottom levels happen first. So for example, the VPC has to be created before the Internet Gateway and before the security group. And the Internet Gateway has to be created before the route table and the primary public subnet, and the route table has to be created before the root table association. So it actually develops a directed graph, a directed acyclic graph. So Terraform understands the relationship between the nodes, and it will actually allow us to walk the graph to manage our infrastructure. Now, managing in this case will be something like creating, updating, deleting, making sure that it's in the correct state, etc. So how does the code look? So firstly and foremost, we declare a provider. Terraform ships with lots of providers. Okay, so providers for AWS, Azure, Google Compute, VMware. It has DN Simple, it has Postgres, it has MySQL. There are lots of graphs, lots of providers that do lots of different pieces of infrastructure. But in this case, we're going to use AWS. There is currently nothing in my AWS account, and I'm just going to show you how we can create some infrastructure right now. So inside a provider, there are a number of resource types. Resource types represent pieces of infrastructure management within AWS or within a given provider. Okay, so for example, a VPC, a subnet, a route table, a security group, etc. We declare the resource. So let's start with the VPC. So VPC in this case has a CIDR block. It allows us to pass specific parameters like whether we want to enable DNS host names and we want to set up tags. If we look at the Internet Gateway above, because of using interpolation, we can actually say the VPC ID that we are creating the Internet Gateway inside is the VPC.default.id, which was created below. So we've actually built a relationship in Terraform now to say, hey, this VPC needs created first, then we can create the Internet Gateway. We've done the same with the subnet, we've done the same with the route table, and we've done the associations. So this is actually what builds up our graph. So if we open the graph again, we can see that we're going to create the VPC, we're going to create the Internet Gateway and the security group, we're going to create the route table, the subnet, and then lastly we'll create the route table association. And if I run the command Terraform Plan, it will take the infrastructure, it will build the graph locally, and it will compare the infrastructure locally against what is currently in the provider that you're targeting. So in this case, AWS. And if I just say plan, it will tell us that I have to create 6 resources. I have 0 to change and 0 to destroy. And we can see that it's got the Internet Gateway, the route table association, the security group, etc. And if I Terraform apply that, and just show you that this doesn't exist right now. So there is currently nothing matching the name webinar. And if I Terraform apply that, it's going to walk the graph again in order to actually make the apply of our infrastructure. You can see that it's creating the VPC first. It's currently waiting before it will continue on until that VPC is available. Then it's creating some security groups, and it's created the subnet, and it's doing because of the directed graph, it understands what can be created alongside each other and what can't. And we can see at the end it actually gives an output to say the apply is complete. So 6 have been added, 0 have been changed, and 0 destroyed. And if we go and refresh our AWS account, we can see at that point that we have a webinar demo VPC. Now, if I just change the tag of that, and I just say Terraform Planet, then Terraform will actually allow me to understand differences between what is currently in production or what is currently on my provider compared to what's locally, and it will tell me what it needs to change. In this case, we can say it's Terraform in this case is going to change webinar demo VPC 222, which I created manually in AWS. It's going to change it back to webinar demo VPC. And if I apply that again, we can see that it's going to change it back. You can see it gets the output of modifying right here, so it tells you what it's doing. And hopefully it's finished, and if I refresh this, we'll see that it's back to webinar demo VPC. So this is a very good way of being able to clarively set out our infrastructure. So everything is written in code. You may be able to follow it, you may not be able to follow it, but everything is there nonetheless, and you can split it out into as many types of files as you want, and you can name things as you want. So we've said that this is in AWS US West 2. For this to be changed to a different region in Amazon, we would either A, have to copy and paste it, and we would say new file, EUWest1.tf, and then find all the instances of US West 2 and US West 1, or US West 2, and then replace into EU West 1. Now obviously this is not very scalable in any way, shape or form, because we don't really want to copy and paste code. We would much rather allow it to be configured in a way that we can pass variables in and reuse the same code blocks. So Terraform has the idea of modules, and we can wrap up pieces of our infrastructure like a VPC, and we can start to say, hey, the subnets, here's the VPC resource, and we can start to use variables and pass them in. Terraform has a complete interpolation syntax, and we can say, in this case, pass in and use the variable that's called CIDR block. We can use the tags. We can say pass in the VPC name. We can actually pass in subnet CIDR blocks and availability zones, and so on and so forth. And how this looks when we pull it out the other end is as follows. So we have a module of VPC. Just going to copy that actually, just so that you can see how easy it will be. Test.tf. Provider AWS. Region equals US West 1. And at that point, there is nothing hard-coded inside the module, which actually says that this is US West 1. And if there's any problems and we need to switch regions in AWS, we just change that value from US West 1 to US West 2. We do the Terraform apply again, and it will roll out the configuration in the new environment. So it's much more scalable, much easier way of doing it. All right, I'm just going to remove that just so that I don't get any extra problems in a demo. Excellent. So I can start to build up an infrastructure using modules. Okay, now I have predefined a key name for this, and if I just go and show you that I have an AWS key pair, which is called TeamCity Webinar. So for the purposes of this demo, I'm going to use that webinar. I'll come back to the availability zones in a second, but I want to roll out a VPC. I want the VPC name to be called TeamCity VPC. It'll have a DNS name. It will go and create a Route 53 zone in DNS called teamcity.local. The CIDR block on the VPC will be that specific CIDR block. It will have two private subnets, excuse me, and it will have one public subnet. And the availability zones that we want to base this VPC across come from a data source, from an interpolation value. Now, data is the new data sources were actually something that was introduced in Terraform 0.7, and we don't every person gets a different set of regions in AWS. Okay, you cannot guarantee that your regions are the same. So in US East 1, or excuse me, US East 1, I could have access to US East 1A, 1B, and 1D, whereas another person could have access to 1B, 1C, and 1E, and vice versa. So when people were running the same Terraform configuration, we thought that it would be pretty bad if we hard-coded values and then the engineers weren't able to use those values. So we introduced the idea of a data source. A data source will actually go off and it will look up that is available to you within a specific region in your account. So the availability zones that are available to me here are 2A, 2B, and 2C, but there is no hard coding of A, 2B, and 2C. So this allows me when I fail over or I change to a different region that I don't need to go and change lots of code in lots of places. I have rolled this VPC out already because I have an RDS instance, which I'll show you. An RDS instance took 20 minutes to roll out, and I didn't really want to waste everyone's time just watching a screen for 20 minutes. I thought it would be much easier to go and start looking at the internals of what it's actually doing here. So every module, we tend to say that a module should have an interface. So as developers, we would program to a third-party interface, and we would be able to pass values to that module. So we would pass in a VPC name, a zone name, CIDR block, etc., etc. But modules can also have outputs. So we want, when Terraform has created our VPC, we want the output of all the private subnet IDs. We want all the output of the public subnet IDs. We want the availability zones. We want the VPC name, the VPC ID, etc. And you can, anything that's available to be, anything that's available within a resource that can be either passed or outputted from a resource itself can actually be outputted from a module. And you can actually do complex interpolation inside and output to format strings or pass variables or pass some information to the users. So what we're actually doing in this module right now is we're saying, hey, create a VPC, create a number of subnets. You'll notice the use of the count interpolation here, where we say we want to create a number of subnets of the length of the number of private subnets that we're passing to the module. Create them in the VPC ID. Here are the slider blocks available for each one. Here are some public subnets. We want to create an internet gateway, a route table association, and then some public routes. We want to create some elastic IPs, and we're going to use the Amazon hosted NAT gateway service. So it's going to go and create that. And then lastly, it's going to create a VPC Route 53 zone, and it's going to roll all of that information out. And if I look at Terraform and Terraform show, then we can actually see at the bottom that we have all of the information already pre-populated because Terraform has rolled it all out for us. So we have subnet 1, we have our public subnet, we have our VPC, which has our route table IDs and our network ACLs, and the various bits of information. If I go and have a look here, that there's a TeamCity VPC already rolled out. And I can see that there are 2 private subnets and 1 public subnet, which if I go back, I can see I specified 2 private subnets and 1. And lastly, I can actually see there are some NAT gateways, which are here. And we have the 2 NAT gateways because we create a NAT gateway per private subnet in that case. And all of the infrastructure is there as expected. So the VPC is up and running and it doesn't really do anything. If I Terraform plan that, Terraform will actually go off and it will show you all the changes that it needs to make of our configuration against what we currently have, as I said. So there are no changes, or rather there should be no changes from what we expected to do. Excellent. And if we look at the graph, we can see a much more complex graph. And I'll talk to you about the RDS part of it in a second. So we can see that the data sources right here have to be actually read, and the information brought back from AWS before the subnets and the route tables are generated. And we can see that the VPC has to be generated before the subnets and route tables come back. And we can start to see how the pieces of our information and the pieces of our graph actually work out with regards to each other. Now, RDS, if you were to go and start to create an RDS instance, it is a bit of a painful process. So we would go and we would launch an instance cluster, and we would have to choose whether it's Aurora or MySQL or so on. So in this case, we're going to try Postgres. And then you would say, is it production? So is it multi-AZ? Or is it just like a dev test instance? We're going to just say dev test in this case. You would choose an engine. You would choose a class and so on. And already I'm getting fed up clicking things in the wizard. So being able to actually specify our database configuration servers as code will already save me a lot of time knowing that I can bring up the same database again and again and again. And we have wrapped this code. So we have an interface which takes a VPC ID, it takes private subnet IDs, the interface identifier, whether it's allocated storage, the class of the database, the master username, the root username and password, and so on and so forth. And we can start to see how simple it is to actually specify our database as a Terraform resource. So we have 22 lines of HCL, which is HashiCorp configuration language, and we can see that we basically pass in every value except for the fact that it's a Postgres engine and its port is 5432, and in this case I don't want my database to be publicly accessible. It should only be accessible to my TeamCity instance. We create some security groups and some subnet groups around that, which allow us to specify where we're actually going to deploy our RDS instance. And it just comes together in a module all wrapped together where we say, hey, the VPC ID of this RDS instance is actually the VPC ID that is created as part of the VPC module from before. So not only were we able to declare some relationships between our resources, but we're actually able to create some relationships between our modules. We pass in a username, password, and an identifier. Notice I haven't hard-coded the password anywhere. So you would usually have to pass that in as a command line variable, or you could set it as an environment variable for best practices. I don't like hard-coding passwords in systems. And lastly, we would say, hey, when this RDS instance is up and running, I would like you to CNAME that. So create a DNS record that actually points from the RDS instance itself to a logical DNS name, which in our case will be pg.teamcity.local. As I said, this is already done because this takes such a long time, but the next part is going to be much more of a live demo. So we can see that we have a hosted zone, teamcity.local, and here we can see we have a pg.teamcity.local, which points to the RDS instance of this namespace right here. And if I try and nslookup.pg.teamcity.local, it has no idea what pg.teamcity.local is because that's not as part of our infrastructure. It's an internal domain only. So just to prove that I can actually bring up infrastructure locally, I thought I'd bring up a tiny VPN. Okay, a VPN will allow me, I can connect to the VPN and I can start to query the database, or I can connect to the database locally, because at that point I'm actually inside my VPC and I can jump around and talk to the private boxes inside. So if I just introduced a new module source right here, so VPN. The VPN is this is not I would class as a production-worthy module in any way, shape, or form. This is just as part of the demo, just to show you that we can bring up and talk to our internal applications by connecting into our VPC. So all it has is a security group, which opens a number of ports. So it opens 22, 443, 943, and 1194, and it allows access out on TCP and UDP for all ports. And then lastly, it brings up a T2 micro instance in AWS, and it puts it in our public subnet, and it just configures it for us. So if I run the command terraform get, it will go off and it will download the module source at that point. Now it's important to note that all of my modules all point to a local source. This source could also be github.com/stack72/my VPN module, or whatever you want it to be, and it will go off and download it. So if you have an infrastructure team that are happy to maintain the modules in a way that the developers don't have to care about them, they can create them in different repositories, and you can specify in Terraform to go off and download those modules at the time in which you're going to use them. For the purposes of demo and for the fact that there's a demo repo, I thought it would be easier if we just put them all on GitHub so that everyone can start to use them. So you have to get the source. So Terraform Plan at this point should show us that we're going to create two things. It should show us that we're going to create an instance and a security group. This is where I'm at the mercy of my internet provider at home now. But there we go. We're going to see plan, 2 to add, 0 to change, 0 to destroy. We can see that the first one is actually a security group, and the one above that is an AWS instance. And if we Terraform apply those, we can go to the AWS console, and when it starts to create the instances, if I refresh the AWS console now, it's going to start to show that it's got an instance being created. I'm really hoping. Excellent. So we have a T2 micro instance. It's in state pending, so it's currently being enabled. And when it's created, it will have some tags. It follows an order of operation. And we can see that it has a correct security group, which is OpenVPN SG. Excellent. Now, Terraform is currently telling you that it's still in the process of creating that instance, and now it has creation complete, and it will give you the summary at the end. If I refresh that, the instance state should now be running. Excellent, and it's going through. It's created the tags as expected, which is TeamCity Webinar VPN. Nope. And it's going through its status checks. Now I've told Terraform at this point to output some information. This is all my code. I need this to be as user-friendly as possible. So I want to give my operators and my developers as much information as they need to. So if they need to SSH into the OpenVPN node, then they'll run the command SSH OpenVPN as at, and then the IP address. And then lastly, we have a link to the VPN web console, which we can take and we can put in the browser when this instance is up and running. It'll just take a few seconds for that instance to actually be healthy. But we can take all that information and we can actually start to give our operators instructions, and this is how our newly formed runbook would be. If I refresh, I'm really hoping this connects pretty shortly. You'll have to forgive this. It's a T2 micro instance, so it's a little bit slow in order to get through all its status checks. Excellent, there we go. Obviously, this is a VPN node. It has no cert attached, so it's definitely insecure, and it's not some way that I would do this in production. But just to show you that we can log into our VPN node when it finishes looking. Come on, little node. There we go. So I can log in OpenVPN, and I have a very super secret password that I've pre-created, and it will allow me to download a user profile, so a VPN client profile, which I'm just going to import into something called Viscosity. And if I connect to Viscosity, It's connected right now. And if I telnet to pg.teamcity.local on 5432, this is where I don't have the port open. Let's just ns lookup it, pg.teamcity.local. Oh, very strange. Just grab the correct name of that. And we can actually see, that's just because I was only using an internal Route 53 zone, sorry. We can see that it's actually got a specific address and it actually resolved, whereas it didn't before. Just to prove that it didn't resolve before, disconnect from my VPN, which I'm disconnected from right now. Look it up. Oh, that's quite embarrassing. Well, let's just ignore that part and skip quite on. So let's just reconnect to my VPN so we can continue as we're going. So I have a VPN at this point, as I said. Open VPN, password. So now we're actually going to create some TeamCity instances. We're going to actually build a TeamCity infrastructure in a scalable way. So we have, so far, just to sum up what we've done, we've created a VPC, which has a number of private and public subnets. We have created an internal Route 53 zone so that the instances can talk internally amongst themselves. We have created an RDS instance for our database, which is Postgres in this case. VPN, a tiny VPN you can access everything from. So TeamCity itself becomes a little bit easier. We're not really going to do a lot. This is where we introduce another tool. By default, a lot of third-party software now just don't package their software. The Debians or what they do is they just give zip files, and then you would follow a specified set of instructions in order to actually always configure the system as they tell you to do. I don't really want my Terraform tool to have to do a lot of that. So I'm going to introduce now a tool called Packer. Okay, Packer is a way that we can create AMIs. Okay, so this is like pre-baked machine images that are built in a specific way all the time because it's declarative in its code. So in JSON, we declare what we need. So Packer is built up of 3 pieces. Okay, it's builders. So actually what it needs to build. In this case, it's going to build an Amazon EBS instance. It's going to use a predefined source AMI. So everything should have a source. Okay, if you're not building for Amazon and you want to build for something like VMware, you would specify like a source ISO of Windows or Linux or whatever that you needed to build from scratch. We give it an instance type that we want to build. We give it username and a timeout and any subnets or security groups, and then we will tell it what AMI to create at the end. So the AMI that we want to create at the end is called TeamCity dash and then a timestamp. And then when that instance is up and running, we want it to follow a specified set of instructions. So we want to apt-get update, we want to install OpenJDK 8, we want to download the TeamCity 10 tar GZ, we want to untar that, we want to make some directories, we want to then go off and get the Postgres JDBC connector. We actually want to make sure that the correct permissions are all in place in order to run our TeamCity script. For all the database or all the folders have the correct permissions on them, and we can just wrap that up in a really simple make file so that we don't have to know any or pass any variables at the command line. So if I just go into Packer TeamCity and if I run the command make AMI, at this point it will go off. And it will, and this is, again, I've pre-baked this earlier just so that I can show, it takes 3 or 4 minutes in order to do, but it will go off, it will pre-validate any AMI names, it will launch any temporary key pairs, and it will try and launch an AWS instance based on what we need it to be. And if I go off and have a look at the correct instance, the correct security group, excuse me, just so that you can actually see it in action. We're just going to use this one right here, hopefully. Strange. What it actually gives you is an AMI output right here. And as you can see, I created this AMI this morning at 12 minutes past 12, just after midday UK time, so that I know that this is the most up-to-date AMI that I needed to use. So if we go back to our Terraform script, I'm not actually passing in the AMI anywhere here. Okay, we want Terraform to be aware of what the AMIs are in our repository and our configuration. So there is another data source called AMI. So Terraform will go off and look up the latest TeamCity AMI, and it can use whatever filter. So it can be name, it can be any specific tag. If it returns a collection, it'll say take the most recent out of the collection, so that we're always using the latest one. Other than that, we're saying it needs a VPC ID, it needs some private subnets, and it needs some public subnets. I'll tell you about that in a second. It needs a key name, how many instances we need to run, and then we need to pass in some Postgres URLs, some information. So Terraform needs to be able to understand the URL of the database, the username, the password, and the database itself, the actual master database name, so that it can build the configuration file. So we have a security group. So this is for the instance itself. So the instance will be active on port 8111. It'll allow me to SSH into it if I need to. We have a security group for the ELB. We're actually going to map the ELB port 80 to 8111 so that we actually don't have to know what port it is on the endpoint. We build the ELB itself. The ELB will be built across the public subnets. And this is really important. ELBs, for me, only go in public subnets if it's a public ELB. Everything else is private. We have a security group for the ELB. It's going to be cross availability zone. It has a listener so that it understands when the instance is healthy, and a health check. We have a launch configuration. Now the launch configuration in this case uses the lookup of the latest AMI ID. It uses an instance type that we declare. By default, the instance type that I have declared in my examples are M3 medium, M4 large. So if you are running this example locally, it will cost you maybe $1 or $2 to try. And it has some user data. So we use user data in a number of ways here. I would pre-bake a lot of this information in, but for the purposes of a demo, this will work perfectly acceptable. So the user data I actually want to bake in is that I want to create the TeamCity database.properties file. So we can create the connection URL, the connection properties of username and password, and Terraform will understand that after an RDS instance has been created, it will allow you to pass that information into the AutoScaling group so that any corresponding instances that need to be created will be spun up using this exact configuration. And then lastly, we want to start the TeamCity server. Okay, again, I would do this in a unit file, or it will be packaged under something like systemd, so that it will be actually a processed environment, and it will actually keep that service running. And then we want the AutoScaling group itself. So the AutoScaling group is going to launch instances in the private subnets we don't want our access to our TeamCity servers directly themselves. It's going to use the launch configuration that we spun up above. It's going to have a desired capacity of how many you want to pass in as a user. It'll have a min and a max as well. And it will create all instances in the AutoScaling group in a specific load balancer. And in our case, it's a TeamCity load balancer. And if I run the command terraform get again, you'll see that it's now downloading the TeamCity module. And Terraform Plan will tell me that it's actually going to create a lot more infrastructure in this case. So it's going to create an AutoScaling group, a launch config, 2 security groups, an ALB. And it'll give me a summary of what it's going to create. And it's all there. And if I Terraform apply that, so I can go and have a look. There are currently no AutoScaling groups in place. And the TeamCity AutoScaling group should be just about to start spinning up right now. If I refresh and I'll have a look at the AutoScaling groups, there we go. We have a TeamCity server AutoScaling group, which is based on a specific launch config. It has 0 servers because we haven't told it. It's going to spin up in these availability zones and these subnets. It has a health check grace period of 60, which we have said, but of course it doesn't have any instances at this point. So let's go and update from 0 instances to 1 instance. Terraform Plan here will actually tell us what it's going to do. And it's going to change it, desired capacity from 0 to 1. And Terraform apply. And when it actually applies it, we'll see the change here from instances of 0 to 1, 0 to 1, and then we'll also see an instance appearing in this AutoScaling group section right here. There we go, it's currently modifying. If I refresh, we'll see that there's now 1 instance currently pending. It's building that instance right now. So I can take that IP address and I can put 8111 on the end, which is our actual TeamCity instance. When it's finished actually bringing the node up, then I'll actually be able to connect to TeamCity and I'll actually be able to see TeamCity at that point. Now remember, this is a pre-configured node. It already has TeamCity installed on it. So it doesn't need to download TeamCity every time. It has already got the data paths and it already has all the permissions all set up and the users installed on it. So you can just launch this and just wait for the time for the application node to boot, and then at that point, that's when you actually have a working node. Come on. It's still going through its initialization check, so you just have to give it a second. As soon as this goes to a green tick or that it has processed some checks, then it's basically classed as an available node at that point. There we go, and we have a TeamCity maintenance page. At this point we can proceed, or we can do, oh, excuse me, and we can start to spin up all of our Postgres information. Now, I haven't hard-coded this in here just because I didn't want to specify some credentials, but we can fill in all the information that we need. And that's actually a question I should ask the TeamCity developers. If I have already selected a data directory, can I rechange that data directory because I've selected the wrong one? And in the purpose of just showing that it's an AutoScaling group, so an AutoScaling group will allow us to destroy the node and it will bring it back up in its place because we have told it that it should have one node available. I have 7 minutes and I have still got a few things to get through, so we're going to destroy this node. So we're going to terminate it. We're going to see that that node disappears. It's gone. So it's in the shutting down phase, and a new one will launch in its place. We're going to force that actually happens a little bit faster. We're going to go to instances. We need to attach that instance, and we're going to add a new instance in its place. So this simulates the fact that we take an instance out of the AutoScaling group, and it's going to replace that that instance. And you can see that a new node is pending. And a new node is currently being spun up right now. It has a new IP address. Let's get it connected to TeamCity right now. Oh, I'm really hoping my internet has not gone wonky. Just while that's waiting, all these scripts are all available. The Packer script, the Terraform scripts, all the different modules, everything is there, so you can go to the GitHub repository and download it. There are no keys currently in it, so you'll have to supply your own AWS access keys. I'm not giving you my keys, I've been caught up with that before. Let's go and refresh it. Let's hopefully see if we can get a TeamCity maintenance page right now. Remember, nothing has changed in our database. This is just the actual instance itself has just been destroyed and a new one has been brought up in its place. And we have a maintenance page. Fantastic. It's loading right now. Hopefully. Come on. There we go, TeamCity maintenance page, excellent. In this case, we're going to say OPT TeamCity data, which is a pre-configured database directory I have. And at this point, it's actually read the database, and it has connected to the database at this point, and it's starting to make TeamCity available for us. It's initializing all the server components, and at this point, we actually have a TeamCity instance. Now, just to show you, I'm obviously on the VPN here speaking to an individual node. We have a load balancer and ELB across the front of this, which is this one, TeamCity ELB, and we can see that there is currently an instance in service, so we've only specified that there's one instance available, and we can take that URL right there, we can drop it into the browser, and we can see that it's actually showing you that an administrator has logged into that box because I'm connected directly to the box in the other tab. But it will give us the ability to disconnect from the VPN and allow us to log in as expected. So the scripts for Terraform and Packer are available in the GitHub repo. I've just got three more slides. Okay, so Mary Poppendieck actually asked us how long it would take for your organization to deploy a change that involved a single line of code, and can you do it on a reliable, repeatable basis? Okay, that question used to be really asked towards software development, but we can very much tailor that question these days towards infrastructure management as well. How long would it take you to be able to change your infrastructure, and can you do it on a reliable, repeatable basis? Using these types of tools, Terraform is not the only tool that's available to do this. You have CloudFormation, you have Azure Resource Manager templates, you have SparkleFormation, you have Boto if you're just in a Python environment and you just want a script. But using these types of tools allows us to create disposable environments. So one of the biggest bugbears I had when I was a software developer was actually having a development environment and a QA environment that replicated production. And if I had had infrastructure as code tools back then I would have been able to spin up environments that mirrored production almost immediately. Lastly, we sort of touched the disaster recovery already, so that if US West 2 in Amazon disappeared, if we needed to respin up our Terraform config in US East 1, it would just be the change of one variable and a Terraform apply, and it would spin out the exact same environment. I don't know if there are any questions. I don't really know if I have any time. Yegor, I guess you can tell me if there are.
Yeah, there are some questions, but I propose we can just answer them in a follow-up when we publish the video, and then also publish the Q&A, and we can provide answers to them in a written form.
Perfect.
Okay, so yeah, thanks Paul. First of all, thanks for joining, everyone. Just follow our blog at blogs.jetbrains.com/TeamCity. We'll publish the recording of this video, and as I said, the answers to some of the questions that you asked. Also follow TeamCity at Twitter at TeamCity, and we'll announce it there when we have it ready. And just to remind Paul's Twitter is at stack72. You can follow Paul. Yeah, whenever we have the recording, we'll announce it. Other than that, thank you, Paul, for doing this webinar, and thanks everyone for joining. Have a good day, everyone.